6.10 Future Developments. Convergence of technology and service. Traditional circuit switched voice service is the key revenue generator for mobile operators. A service such as SMS has a considerable share in the mobile operator revenues. Although Although mobile data has been a limited contributor so far, in fixed network there is already a shift from traditional voice service to internet-enabled application for conversation such as VoIP and Skype. This could include video telephony as is the case with Easy Skype. Hence, the clear difference between telephony and data is disappearing. With the increasing data transmission speeds, this is also likely to happen in the mobile environment. VoIP service and proprietary voice over internet application will be applied on mobile broadband network. Voice is no longer synonymous with telephony. Also, data networks become carriers for voice. Regulation for a voice service is difficult to separate from data service regulation. Assuming a circuit switched call of 10 minutes will be compressed 64 kbps to a data volume of approximately 5 megabytes, with the wholesale voice being regulated at 0.30 per minute. This would be equivalent to a data roaming rate of 0.60 per MB. This could also be looked at from the data perspective. Is a roaming call if a roaming call using VoIP has been executed and 5 MB data volume was required. Should the call be more expensive than 0 by 60 per MB? What if that some VoIP call could be compressed to 2 by 5 megabytes? Another prevalent developments in the mobile environment concerns integrated solution for GSM data roaming and Wi-Fi. This allows for using the local Wi-Fi networks data roaming to send and receive calls using the GSM directory number. Roaming between GSM and Wi-Fi is supported, as well as handovers between the networks. This application is called Unified Mobile Access UMA. Example of data roaming. These services are Unique, Orange and Fusion. 6.10.2 IMS. The introduction of IP multimedia subsystem IMS is a key development in the ongoing process of further developments of the concept of management service in the mobile industry and the initiation of new service in that same industry. The developments of the EMTS standardization came about step by step. The specification of the development of the UMTS standardization came about step by step. The specification of the functionalities both for radio network components as well as for core network components is delivered in releases. The first deployable version was released 99 that primarily consisted of the WCDMA radio access system. Release 5 amongst other items contains HSDPA as well as the first phase of the IP Multimedia Subsystems IMS. Release 6 contains enhancements to IMS HSUPA, multiple input, multiple output MIMO, antenna systems for higher user data rates etc. The basic concept of the IP multimedia subsystem IMS is to offer internet service everywhere at any time using uh, cellular network technologies. In IMS, the merging of the internet and of the cellular networks takes place. The separation into different domains for uh, circuit switch service coming from the traditional world of telephony and packet switch service introduced by GPRS and enhanced by UMTS will disappear. The mobile terminals of today can support virtually any service that can be used by a broadband internet connection such as ADSL. There is a need for IMS for a number of reasons. IMS will provide the improvement of quality of the service QoS. It will improve charging capabilities for multimedia sessions and will improve the interrogation of different service. End user knowledge awareness. A customer may not know what a megabyte is. A kilobyte is 1.0.240 bytes and a megabyte is 1.0.48 by 576 bytes. This will mean that data pricing is difficult to comprehend if it is expressed in per megabyte. In general, customers who do not have the technical knowledge to understand how much data is being used will have difficulties understanding how much data is transmitted for a certain service and thus will find it difficult to fully understanding the cost for the transmission of the data. In addition, the customer may not be aware of the speed of data transmission, expected data volume versus actual data volume. There may be retransmissions of data due to transmission failures leading to higher data volumes than expected. Easy for laptop computer users, there may be unexpected and unintended data volumes. Software maintenance, downloads, autonomous internet activity by software application, spam etc. Particularly for laptop computers users, but also for PDA and BlackBerry users, there are difficulties in uh, managing the data volumes that are transmitted. Additional comparison of data in the mobile radio networks may take place. Data volume charging. A mobile operator may round up data session to block of e.g. 10 kilobytes. This means that short data sessions are charged at a higher price and than expected. There is a difference between bursty traffic, many short low volume events, and streaming like service. One very long high volume event, the customer is not aware of the number of data sessions for these events and how this affects the charging of the data volume. 6.9 Predictability of usage cost. For voice, the predictability of cost. The relatively high. In general, customers are aware the roaming rates are higher than national rates. Usage is charged on the basis of minutes, which is easy for a customer to understand, and it is easy to keep track of the uses. For data, this is totally different. First, the customer is generally not aware of the data roaming charge. This is mainly because national usage is usually charged within a bundle, so the customer knows the monthly data cost but not the data volume used nor the price per MB. Secondly, it is hard for a customer to keep track of the data volume used when abroad. When using a laptop browsing the internet, it is very easy to use more than per MB session. Being abroad for a period of 2 weeks and browsing the internet once a day can generate bills for over a 1000 at a rate of 750 per MB. If a video easy at YouTube is watched using a mobile phone at a speed of 80 kbps, a video of 1 minute would take 600 kb. Supposing the data roaming rate is 10, 1000 per MB, watching this video would cost 600. A 10 minutes video is a news update would cost 6000. If a movie is watched using a mobile phone at a speed of 384 kbps, a movie of 2 hours would require 346 MB. Supposing the data roaming rate is 0.10 per MB. Watching this movie would cost 34 3456. Figure 8 Typical uses and data size. It should be noted that actual data volumes required for sending image, audio or video will depend on resolution of the data. Higher the resolution, the better the quality of the reproduction and the better the original can be matched. However, higher resolution leads to larger data volumes and occasionally more expensive data sessions. The resolution is expressed easy in bits second in case of audio or in pixel cm in case of a picture. For a consumer for a consumer to comprehend the amount of data required for a certain data transfer like video, audio, etc. The quality of the service is of influence in terms of the acceptable charge for such a service. This is a matter of price quality evaluation. As an example, when watching a movie or a TV program using a mobile data, better service, a news reader sitting quietly behind a desk, hardly moving, would allow a much lower resolution and fast data volume than a football game or a tennis match that would need much higher resolution and higher data volume. For the customers, this would result in different cost for TV programs that have the same time duration. 6.8.2 Measuring the volume of data uses. In charging for data service to subscribers, there are a number of issues that could cause lack of transparency about users. Have part of their own packet choice network and an SP that uses the MNO core network. The mobile operator, even in the MVNO scenario, has the ability to be in control of the service delivery, access the subscriber of availability of the network, technology and service to third parties, monitoring and defining the quality of service for the service delivered, wholesale charging of data volumes. It should be noted that for service delivery, third parties such as MVNOs and SPS highly depend data roaming on the mobile operator for the configuration of their products to data roaming the market. In practice, these third parties have limited controls over the service delivery and need to negotiate and agree with operators in order the in order to be able offer data service. In addition, if value added service such as SMS, MMS, BlackBerry, PDA support, content service, etc. are required, this also needed to be negotiated with the mobile operator before they can be implemented. The become available to the MVNO or SP. 6.8 Typical uses. For consumer of voice service, there is a common understanding that time is the unit for charging of the service. This common understanding has been slightly influenced by star traffic and minute bundle. In general, data roaming consumers understanding that the duration of a call determines the cost. For data roaming service, data volume, the common unit for charging of the service is expressed in kilobytes or megabytes. It should be noted the for noted that for the Average non-technically educated consumer data volume is a concept that is difficult to apprehend. Is the consumer aware that 1 byte is equal to 8 bit? Uh, perhaps it is assumed that 1 kilobytes equal 1000 bytes and that 1 megabyte is 1 kilobytes when in fact data roaming with 1 kilobyte equal 1.0.24 byte and 1 megabyte is 1.024. 1 kilobytes is 1.0.48.50 576 byte. 6.8.1 examples. Some examples of typical uses of data service area as follows. Email. A short email containing just a single sentence of 10 short words is approximately 4 KB. Internet page. A very simple web page in HTML format without image would contain approximately 25 by 50 KB, although at website containing some basic imaging would be approximately 150 by 250 KB or more. It should be noted if internet pages content animated pictures, banners and video streaming, then the data volume will further increase. File. A file in Microsoft Word consisting of an A4 page text is approximately 26 KB data roaming. Image. A JPEG coded pictures data roaming size 10 is to 15 centimeter and a 100 pixel centimeter is approximately 488 KB. Low level of comparison. High quality picture, audio and MPEG audio player MP3 coded music song of 3.32 minutes sample at 4320 kbps will take 8 by 3 MB. Video and MPEG coded video 608 is to 4.52 of 2.12 minutes will take approximately 40 MB. These examples are depicted in figure 8. Creates dedicated prices plan. Often the operator charges a combined traffic and tariff for the data access and the use of the service. Usually there are no separate charges by third parties. These concepts of service-based pricing is further uh, specified in chapter 7.3.3.3. Examples of this area: BlackBerry service, magazine service, MMS mobile TV application to support a company's business processes, etc. For managed service, the customer ownership is with the mobile operator and the invoicing for this is also taken care for by the mobile operator. In general, mobile operators offer the unmanaged and the managed model in uh, parallel and in competition with each other. In some cases, operators have blocked customers from using, for instance, Skype service when using mobile broadband. In general, mobile operators offer the unmanaged and the managed model in parallel. In competition, Skype device when using mobile broadband 6.6 device. For voice, a customer needs a mobile phone in order to use the voice service. For data service, a much wider variety of devices is available and necessary to use the service. Laptop computers combined with built-in SIM cards and data modems, or with separate cards or modems, these devices are often dedicated for data users. Smartphone PDAs, often this device combine voice and data service on the same device and SIM cards. Devices for push mail like BlackBerry, often this device combine voice and data service on the same device and same SIM card. In particular, in the early days of data service, the unavailability of compatible device was one of the device was one of the factors limiting the growth of data service. The device used is also important from a roaming traffic service perspective. It is important to understand for what kind of uses the combination of SIM and device is intended. For instance, laptop customers are best sent to networks differing HSPA technology. In order to offer the best customer experience, if voice and data are combined in the same device SIM, the operator needs to decide to which network the customer will be spread. Either the network that offers the best wholesale voice rate or the network offering the best wholesale data rates and or data transmission speed. Device may have a certain preference concerning the selection of networks. For instance, UMTS enable device might be have a preference for UMTS enable networks. In this way, the customers will be offered the best service available. 6.7 Delivery of data service by MVNO or SP. Parties such as mobile, virtual networks operators, MNVO, or service providers SP could also deliver data service to their end user based on a wholesale agreement enabling them to use the mobile network's infrastructure or part of that infrastructure. The mobile operator allows end user of these third parties to enter the networks and use data service. The data service could be equivalent to the mobile operator's own retail service and resold to the end user, or they could be data service that are specially designed and implemented for the MVNO. In this situation, there is a different approach for MVNSO. email etc. improvement of latency is leading to the updates of voice and video calling service using internet 6.5 management versus unmanagement service. Mobile access environment, fixed access environment, managed model, mobile service environment, unmanaged model, internet.